The paper Effects of Fast Food Consumption on Energy Intake and Diet Quality Among Children in a National Household Survey investigated the effect of fast food consumption on other dietary variables. For a sample of 663 teens who reported that they did not eat fast food during a typical day, the mean daily calorie intake was 2,258 and the sample standard deviation was 1,519. For a sample of 413 teens who reported that they did eat fast food on a typical day, the mean calorie intake was 2,637 and the standard deviation was 1,138. Part A asks us what assumptions about the two samples must be reasonable in order for the use of the two-sample t confidence interval to be appropriate. So we have two groups here, each with a mean and a sample standard deviation. For a two-sample t-test or t-interval, we need two independent random samples and either approximately normal populations or large sample sizes. In this case, both of our samples were large samples. So we had a sample of 663 and in the other group we had a sample of 413. Those are definitely large. So we don't need normality, but what we do need is two independent random samples. Nothing is given about that, so that's the assumption that we need to make here. We must assume that the samples were independent random samples from the populations. Part B says use the given information to estimate the difference in mean daily calorie intake for teens who do eat fast food on a typical day and those who do not. The first thing we need to do when we do a confidence interval is check the assumptions or the conditions for that interval. We already discussed the assumptions in Part A, but this is a necessary step for all confidence intervals, so we'll go ahead and state them again. So first of all, do we have a random sample? We stated in Part A that we must assume that the samples were independent random samples from the populations because it wasn't specifically given. The next condition that must be met for a two-sample t-interval is either normal populations or large sample sizes. We mentioned before that we have two large sample sizes. The first one was 663, the second one was 413. Both of those are greater than or equal to 30, so we can now proceed with a two-sample t-interval. So now we're ready to actually calculate the confidence interval that will estimate the difference in the mean daily calorie intake between these two groups. So let's start by organizing the information in a table. So we have two groups here. One is a group that did not eat fast food on a typical day, and the other is a group that did eat fast food on a typical day. Then for each group we have three bits of information. We have n, the sample size. We have x bar, the sample mean, and s, the sample standard deviation. So let's go ahead and fill in this information. For the group that did not eat fast food on a typical day, it says we sampled 663 teens who reported that they did not eat fast food during a typical day. So 663 is our sample size. The mean daily calorie intake was 2,258 for that group, so that goes right in here for x bar. And the sample standard deviation was 1,519, right in there. Similarly, for the group that did eat fast food, we had a sample size of 413. We had a mean calorie intake of 2,637 and a standard deviation of 1,138. So now that we have all of that information put into the table, we can put this information into the confidence interval formula for the difference between two means. And here's our formula. We have our statistic, x bar 1 minus x bar 2, plus or minus a t star, our critical value, times the standard deviation of this statistic. The standard deviation of x bar 1 minus x bar 2 is this square root here. Now t star comes from a t-distribution that has this degrees of freedom. Not a very easy computation there. Just takes a little bit of time. So in order to find this t star, the critical value, we need to know the degrees of freedom. So let's go ahead and do the degrees of freedom first. So let's go ahead and fill in some information into our degrees of freedom formula here. To start with, let's label this group 1 and this group 2. So this would be our N1, this would be our X bar 1, and this would be our S1. Similarly for group 2 there. So we're going to say S1 squared, so that's going to be 1519 squared divided by N1, sample size of group 1 is 663, plus S2 squared is 1138 squared divided by the second sample size is 413. Now we need to take all of that and square it. There's our numerator. Now in the denominator, we're going to have something kind of similar here. We're going to have a 1519 squared over a 663, but this time we're going to square that single fraction, plus an 1138 squared divided by a 413. And we're going to square all that, and I forgot the denominator over here. N1 minus 1, that's 663 minus 1 is 662. Similarly over here, we're going to have a 412. All right, so let's go ahead and pull out our calculator here. Okay, so I'm going to start with this 1519 squared. 1519 squared divided by this 663 plus 1138 squared divided by 413. Okay, we have that large number. We need to square that, and that is going to be our numerator here. So let me transfer that number over here. I think we have 43769898.1 over. All right, so let's get our calculator pulled up here again. And we're going to work on the denominator. So I need 1519 squared divided by 663. Then I want to take that value and square it. Then I want to take that value and divide it by 662. And it looks like we get about 18,295. Let me go ahead and jot that down here. So it was approximately 18,295.57441. Plus, let's do the same type of thing for this other fraction here. Get my calculator up again. Okay, this time we need 1138 squared divided by 413. That number squared, and then that number divided by 412. And we get 23,865 and a little bit left over there, so let me write that one down. 23,865.56546. Okay, now I'll trust that you could figure that out on your calculator, and we get a degrees of freedom of about 1,038.15737. So let's go ahead and round up to 1,039 degrees of freedom. Let me go ahead and jot that down on this next slide here. We're going to have degrees of freedom of 1,039. Okay, now we want to actually calculate this interval here. So x bar 1 was the mean of the first group. Remember that one was 1 and this one was 2. So x bar 1 is 2258 minus the other sample mean was 2637. We have that value plus or minus, and here's where our critical value comes in. We need to go find the critical value, T star, for 1039 degrees of freedom. This particular problem did not tell us what confidence level to use, so I'm just going to go ahead and pick one. Let's say we use 95% confidence. That's a fairly standard one, so that's what I'll use here. All right, so I'm going to pull up my table here. This is my T critical value table. We want 95% confidence, and we want 1039 degrees of freedom. If we go down here, our table only goes up to 120 degrees of freedom for 95% confidence. Well, we have many more degrees of freedom than that, so we're just going to use this row here, which is actually the Z critical values, as n, your degrees of freedom, goes to infinity. So we're going to use 1.96. So a 1.96 here times the square root of standard deviation 1 squared, so that's actually the variance, but we'll do 1519 squared over 663 plus 1138 squared over 413. Okay, 2258 minus 2637 is negative 379. Plus or minus, let me use my calculator and figure out this other value here. Okay, we'll clear out what we had there before. So I'm going to start with this 1519 squared again. 1519 squared divided by 663 plus 1138 squared divided by 413. So we've got that value. Then we want the square root of it. So I want the square root of that number before. And then we want to multiply that by 1.96 out in front there. Oops. Let's go 1.96. So 159.4226248. Let's get that one over here. 159.4226248. So if we take negative 379 minus that 159, we get approximately negative 538.4226. And then if we take negative 379 plus that 159, we get negative 219.5774. So there's the confidence interval estimating this difference. Our last step is to interpret the interval in the context of the problem. We are 95% confident that the mean daily calorie intake for teens who do not eat fast food on a typical day minus the mean daily calorie intake for teens who do eat fast food on a typical day is between about negative 538 and negative 219. If you look at the order in which we subtracted here, we took those who do not eat fast food, their mean calorie intake, minus those who do, and we got a negative number. That means that teens who do eat fast food on a typical day have a higher mean daily calorie intake.